Hello students, we are back after a long time. We'll be covering the remaining parts of the class 11 physics. Till date, we have studied chapter 1 and chapter 2. That is, under class 11, we had part 1, part 2, class 12, we had part 1, part 2, and under class 11, part 1, which covers the motion of objects. In addition, unit and measurement, and another one is physical world. Now, under motion of objects, we will be studying linear motion, rotational motion, and gravitational motion of objects. Now, under physical world, we have studied what is physical world and physics. What is fundamental forces and energy and the law of conservation of energy. Now, under physical world physics, we have studied what is physical world, what is physics, and what is categories of physics. We know what is physical world. Physical world is the world we see around us. This is nothing but the nature we see around us. We see around us is the physical world. That means the objects we see around us constitute the physical world. Physics is the study of this physical world, that is, study of this nature and natural phenomena. That is a branch of science. Physics is branch of science in which we will study nature and all natural phenomena. Natural phenomena are the what are the activities going on in nature. This nature constitutes bigger particles and small particles. That is, sometimes it will be visible to some quantity items which are visible to naked eyes, and some are very small. We need instruments to see those particles. These are very small particles, and these are the big objects, we can say. These big objects, we say macroscopic particles. Macroscopic. But the small, we say microscopic particles. Now, these big particles constitute Earth or terrestrial objects and heavenly or celestial objects. Now, once we will study these macroscopic particles or objects, we say this is our classical physics. Whereas study of these microscopic particles will be termed as quantum physics. Now, under categorization physics, we will categorize into two groups. One is classical physics and another one is quantum physics. Now it is clear what is classical physics. Classical physics will be the physics that will cover our all bigger objects or macroscopic particles and objects. Now, this classical physics again will be divided into four categories depending upon uh, the main constituent what we refer. It will be our mechanics, electrodynamics, thermodynamics, and optics. Optics that will deal with light, thermodynamics deal with heat flow, electrodynamics will deal with electric charge, whereas mechanics will deal with objects having mass, and mostly it will be deal with motion. Next is other fundamental forces. Under fundamental forces, we'll have four major categories of forces. One is our gravitational force, another is our electromagnetic force, and third is strong nuclear force. Another one is weak nuclear force. Now, this gravitational force will be existing when there is objects having certain mass. That means the force of attraction between two objects having masses. This force will be characterized by it is always attractive force and it does not require any media. No media it requires. That means whether it is kept inside air, again this force will come in existence. If it will be kept in space also, then also there will be some force of attraction between two objects, and this is a gravitational force. Now, electromagnetic force that will be between charges. If charges are raised at rest, so charge 1, Q charge first charge Q1, it will have its electric field Q1 at rest. Due to this charge, we will have an electric field, and any other charge kept in this electric field Q2, it will exert one force on this. Depending upon the type of charge, this will be either attractive force or repulsive. If Q1, Q2 has same or like charges, then there will be repulsive force. If Q1, Q2 are of opposite charge, then it will be attractive force. Now, if charges are in motion, then Q1, once it is in moving, it will create magnetic field and it will have one force on another charge in motion. Magnetic field and V. This magnetic field will have a force on this Q2 and this will be either attractive or repulsive depending upon the direction of this Q2. Now, the third one is strong nuclear force. Strong nuclear force means this is the force between particles inside nucleus. We know inside nucleus there is proton and neutron. That means the force between proton or neutron or between proton and proton or neutron and neutron. This is the strongest force. It's more than the electronic force, and this electronic force is more stronger than this gravitational force. Another one is this weak nuclear force. This comes into existence during beta decay of nucleus. The third one is energy. Under energy, we know what is energy, what is types of energy, and law of conservation of energy. Law of conservation energy says energy cannot be created nor can be destroyed. Cannot be created, cannot be destroyed, but it can convert from one form of energy. Types means different forms of energy. Different forms of energy, like we have light is electricity, heat, all these are different forms of energy. When coal is burnt, electricity is produced, then electricity again it is converted again to light, or again this electricity can convert to heat. Likewise, one energy gets converted to from one form to another. That's why it's a law of conservation says energy cannot be created nor destroyed, only it can transform from one form to another. Hence, total energy in the universe remains constant. This says law of conservation of energy. With this, we have started this much we have studied under physical world. Next chapter we have studied that's our unit and measurement. Under unit and measurement, we had studied what is unit and system of units, what is errors in measurement, significant figure, and measuring instrument. And last is our dimension. Under unit and system of units, we have studied two types of units, that is fundamental unit and derived unit. This depends upon the quantity we are going to measure. Fundamental units are for fundamental quantities, derived units are for derived quantities. Whereas system of unit, we have four types of system of units. One is M, K, S. Another is C, G, S. This F, P, S. And last one is SI system. This MKS system is for giving a system of units for fundamental quantities. One is we have fundamental quantities, fundamental quantity it is mass. Another fundamental quantity is length, and another one is time. When unit of this mass is kg, for unit of length is meter, and unit of time is second, this system of unit is termed as MKS system. Similar way, when unit of mass is our gram, unit of length is our centimeter, and unit of time is second, this system of unit becomes CGS system. Similarly, when unit of mass is pound, unit of length is foot, and unit of time is second, the system of units becomes FPS system. It's a British system. Now, the last one is the international system. International system of units. This is a modification of MKS system. In MKS system, we had three three fundamental quantities. That is mass, length, and time. In addition to that, we will have four more fundamental quantities in this SI system. That's the SI system is the MK system with four more fundamental quantities. Four more fundamental quantities are: one is temperature, next is number of quantities, whose unit is mole, unit of temperature will be Kelvin, electric current unit will be ampere, and luminous intensity linked to light, that unit will be candela. With this, we could had covered unit and system of units. Unit is the fundamental or basic quantity of same kind, which is taken as a reference during measurement of any quantity. That means unit is used for measuring of any item. Measurement is nothing but it's a comparison with certain basic standard of same kind. This basic standard is the unit. When the item we want to measure will be compared, will have some numerical, that means how many times it is bigger. If this is a 1 kg mass, this compared it became 3 times bigger. That means measurement for this item will be 3 kg. That means it's shown measurement of any item is a comparison with certain basic standard, and this basic standard is internationally accepted one, like 1 kg mass is 1 kg everywhere, and any other mass that will be compared with this 1 kg will find some numerical figure, and then this unit will be added to it. Now it will show the measurement of the item we have measured. Likewise, for any liquid, if you want to measure, it will be compared with its unit. If it is 3 liter, that means it is compared with 1 liter unit. Then it shows 3 times more than this 1 liter. Hence, the item or liquid measured is 3 liters. In physics, we will have 3 fundamental quantities basically. Later stage, we have added 4 other fundamental quantities. Now, when we consider these 3 fundamental quantities, other quantities which are formed by combination of these quantities, it is termed as our derived quantities. For example, when we talk about force, force is nothing but mass and acceleration. For mass Mass is a fundamental quantity, whereas acceleration is rate of change of velocity or velocity by time. Again, velocity is rate of change of distance or displacement. Velocity is displacement by time or divided by time. Now displacement is magnitude of displacement is distance, that is length by time into time. Now it became mass into length by time square. Now we could express this force in terms of mass, length and time. Let's say it is termed as fundamental quantity. Next one we have studied is errors in measurement. Under this, I have studied other types of errors and mathematical operation on errors. Types errors is absolute error. Another one I've studied is relative error and another one is percentage error. This error is nothing but the deviation of measured value from its true value. When there is some difference, this shows the error. It is a true value. Once we measure, it should be as true value. But due to some error, due to some phenomena, it may be due to machine, technique, or man, this measured value became different from this true value that caused error. Error can be expressed in different way. In absolute, it may be like absolute error, or it may be relative error. Relative error is nothing but absolute error by assumed true value. This absolute error is nothing but the mean absolute error. This is for any quantity if a number of measurements are being carried out, A1, A2, let A3, so on. The average of these measured values will be taken as our assumed true value. This is equal to a mean. Now, in each measurement, we find some error, that's am minus a1. In this case, error will be am minus a2. And in third case, the error will be am minus a3. These are the errors. It may result in either way. If this will be bigger, positive, or this will be bigger, it's negative. That's what we'll do. We'll take mod of this. Delta A1, delta A2, delta A3. Once mod is taken, this will result always positive values, and mean of these absolute errors, these absolute values of errors and then mean is taken. This is the our mean of absolute error or absolute error. This is the absolute error. Now, when you compare this, we find delta AF by AF is our relative error. Now, once we found out the relative error, if relative error is multiplied by 100, gives the percentage error. Let us discuss on mathematical operations of error. It indicates if any quantity whose work is, as we know, it is a multiplication of force and uh, distance. When we want to find the error associated with this final quantity, what we want to do, suppose if we know the error of this quantity and error of this quantity, we can find out what is the error of this quantity by this method we adopted. That means if any quantity is either addition or subtraction of different quantities, or quantity may be multiplication or division of different quantities. In that case, we'll, for addition and subtraction, we will find absolute error of quantity 1, absolute error of quantity 2. Then we'll add both. We'll find the absolute error of our quantity of requirement. That means if Q is Q1 plus Q2, then absolute error of Q will be absolute error of Q1 and absolute error of Q2 added together. If the quantity is Q1 minus Q2, in that case also absolute error will be addition of errors. Similarly, if any quantity is multiplication of two other quantities, then here we'll take relative error of Q1 is equal to relative error of Q1 plus relative error of Q2. If this quantity is division of two different quantities, in that case also relative error of this final quantity will be addition of their relative errors. The next topic was significant figure. Under significant figure, we had studied the rules to find out the significant figure, mathematical operation on significant figure, and last is rounding of significant digits. What is significant figure? In that we had studied. Significant figure is nothing when measured value has certain digits and a number of uncertain digits in its result. That means the certain digits, whether we measure a number of times, this will remain always, it will not vary at all. And If in due course of different measurements, these uncertain digits will vary. Now, when you consider these certain digits plus first uncertain digit, these constitute our significant figure. Now, if two quantities are added or subtracted or multiplied or are divided, then in that case, we'll be referring for multiplication division, we'll be referring significant figure, the digit having lowest significant figure, and in addition subtraction, we'll be referring decimal point or the quantity having lowest decimal point. Now under rules, we have whether this digit is decimal or non-decimal. In decimal case, we'll have all non-zeros are significant. In non-decimal also, all non-zeros are significant. Then zeros between non-zeros are significant. Here also zeros between non-zeros are significant. Now here trailing zeros and leading zeros. Again here trailing zeros and last zeros, and these leading zeros are starting zeros. All these leading zeros will be non-significant in our non-decimal points.